In the last section, we spent a lot of effort learning some new tools, tricks, and techniques to help us simplify things. In this section, we have the task of trying to take all the things we've learned so far and combining them together to try to decide which things make the most sense to use when. Now, the good news is that we're going to kind of take a second to collect our thoughts and see which tools we've learned. The bad news is that I can't promise you any sort of deterministic advice that's going to say, when you see this, do that. When you have A, do B. Instead, what I want you guys to think about is, okay, if you see a tool that you think might work, try it. But don't be afraid to take a step back and start over again. Okay, there's no guarantee that the thing you try is going to work out well. There's no guarantee that if you find a solution, it's going to be the same as your neighbor's solution. Okay, so we're on the lookout to find any path from point A to point B here. And to do that, we're just going to start by refreshing ourselves on all the tools we've learned. Okay, so last section we spent a while factoring trig expressions. Sometimes that can be useful. Another tool we did is combining fractions. Okay, so just getting a common denominator. Sometimes it's useful to expand expressions raised to powers. We'll see what that looks like in a little bit. Sometimes we end up simplifying denominators. Okay, so that could be useful. Think in particular about how we use those Pythagorean identities to make the denominators look better last section. Sometimes just straight up you see a fundamental identity you can use. That's a thing you want to keep in mind. And then also, converting things to sines and cosines can be very useful. Now, there's no particular priority here. I'm not saying one is better than the others. This is just kind of a list of stuff we've done in the past. The one guiding principle I'll give you for basically every problem, though, is if you're supposed to prove something, like maybe this guy right here, you want to start with whichever side looks more complicated. So in this one, sine squared looks pretty safe. The right side, though, that looks pretty complicated. So that's where I'm going to start. Okay, and just to reiterate, this is far more art than science. Okay, I can't promise you that I'm going to do everything right the first time. I can't promise that you're going to do everything right the first time. Sometimes we have to try, see if it works, and then if it doesn't, step back and try it again. Okay, don't be afraid to fail or to make a mistake or to not go down the right path. Doesn't matter how long you've been doing this, sometimes it's just going to take trial and error until you find a way that works. Okay, so let's try this first one together, and then I'm going to have you guys try a few. So for this one, okay, I need to start by deciding which side is more complicated. Yeah, it's definitely the right side. So I'm going to write out the right side. And I'm just going to do the first thing that occurs to me. I've got a trig function squared and a 1. So I bet there's a Pythagorean identity that I could use there. Okay, thinking about my Pythagorean identity. Tan squared theta plus 1 equals secant squared theta. So let's solve for secant squared theta minus 1. Okay, so I'm going to replace the top with tangent squared theta. Okay, so now I have tangent squared theta over secant squared theta. I don't really have anything nice to divide tangent by secant, so why don't I go ahead and convert everything into sines and cosines. Alright, so tangent is sine over cosine. So that means tangent squared is sine squared over cosine squared. And on the bottom, secant is the same thing as 1 over cosine. So, instead of dividing by a fraction, let's multiply by the reciprocal. Cosine squareds cancel out, and I've got sine squared theta. So let's see, is that where I wanted to end up? Yep, lucky for us, that's exactly what I was supposed to get. So I started with one side, and one step at a time, I manipulated until I got the other side. Okay, so this is our first example in this section of proving an identity. We've done this a little bit before, but as you've noticed, we've really expanded our tool set. We have a lot more options at our disposal, so it takes a little bit more brain power to figure out a valid path. If you're thinking to yourself, man, I did this a completely different way, but I still got the same answer, that's completely okay. Right, here's another way I could have done this one. If I started with this right side, I could have broken this apart into two fractions. Right, secant squared theta over secant squared theta minus 1 over secant squared theta. If you do that, this first one becomes 1, and 1 over secant is cosine, and 1 minus cosine squared, according to the Pythagorean identity, is sine squared. So there's multiple ways that you can solve these problems. Don't be afraid to do a way that looks different from what you see in the textbook, or in my notes, or on your neighbor's solution. Any valid solution is valid. Okay, so if you find a way to get there, that's great. Alright, let's try a few more of these, just keeping in mind all these tools that we've learned. Okay, so here's our new problem. I'm going to just go back to that list of tools, see what you can do to prove this one. So decide which side is more complicated, then try some things out and see if you can get to the end. So go ahead and pause the video and give this one a try. So without a doubt, the more complicated side, definitely the left side. So I'm going to start with that. Okay, so the first thing that occurs to me is I've got sine squared plus cosine squared. That's a Pythagorean identity, so I'm going to replace the top with 1. Okay, so that helped. Next thing I notice, if I'm looking at the bottom here, cosine squared and secant squared, why don't I try to rewrite that with sines and cosines? Well, that ends up being really convenient. Cosine squared over cosine squared. That's 1 over 1, which is just 1. So I started with the left side, I ended up with the right side, so that is one of many different paths I could take to prove this guy. Okay, let's try another example. Okay, once again, I want you to go ahead and pause the video, see what you can do with this guy, then unpause and see what my solution is. Yours doesn't have to be the same as mine, I just want to see what you can do with it. So if I'm trying to decide which side looks more complicated, I guess the right side looks more complicated here. So if I'm going to start with the right side, let's go ahead and write it out. That's just the Greek letter beta. Alright, so thinking about my toolbox, I'm thinking maybe I want a common denominator here. So the first one's going to get multiplied by 1 plus cosine beta over 1 plus cosine beta. The second one's going to get multiplied by 1 minus cosine beta over 1 minus cosine beta. Multiplying those guys out, I've got 1 plus cosine beta plus 1 minus cosine beta over, and if I FOIL those guys out, 1 minus cosine squared beta. Well, I'm going to have some stuff cancel out. 1 plus 1. Alright, so I've got 2 over 1 minus cosine squared beta. Well, let's think. What is 1 minus cosine squared? I'm seeing a 1 and a trig function squared. That makes me think maybe I can use a Pythagorean identity. The more we do those, the fresher we'll get with them. So yeah, 1 minus cosine squared, that's sine squared. And the nicer way to write 1 over sine is cosecant. I've got 2 cosecant squared beta. And that's exactly what I was hoping to get to. Okay, one more example before we move on to a new video. See what you guys can do with this one. Okay, pause your video, see what you can do. I definitely think the left side looks more complicated here, so let's start with that. So I'm going to go ahead and just see what comes to mind. I've got a tangent squared and a 1. That makes me think of Pythagorean identity. Okay, tan squared plus 1 is secant squared. So that's not so bad. I've got lots of options for how I could proceed from here, but I see another trig function squared and a 1. So I'm thinking maybe I've got another Pythagorean I can do. So let's manipulate that really quick. I want cosine squared x minus 1. So if I subtract 1 from both sides and subtract sine squared from both sides, cosine squared x minus 1 is negative sine squared x. Okay. So I'm making some progress. I don't really know what I can do with sine and secant. Let's just go ahead and rewrite everything in terms of sines and cosines. Maybe that'll help. Well, at this point, I've got sine over cosine. So that's negative sine squared x, cosine squared x, which I could just write as negative tangent squared x. And that's exactly what I was hoping to get. Okay, so the takeaway here is there's not one magic solution. There's no golden advice I can give that's always going to lead you down the right path. You just kind of try something and see if it works. If it's not working, or it's seeming like it's going off in the wrong direction, just put it on hold, step back, and try something else. Okay, there are lots of different correct answers, and as long as you can get from the start to the finish, that counts as a correct answer.